So in the previous tutorial, we have discussed about this, that whenever you have null and alternate hypothesis, and when you're trying to compare more than two populations, be it parametric or non-parametric tests, you'd be stuck with a few scenarios, such as say your output variable is turnaround time and your input variable is the three suppliers A, B and C. Now when we have composed the null and alternate hypothesis from ANOVA perspective, this is how we have composed. Null hypothesis was transaction time of all three suppliers is same, and alternate hypothesis was at least one supplier's transaction time is different. So in ANOVA test that we have done, one-way ANOVA, we failed to reject null hypothesis. So turnaround time or the transaction time of all three suppliers was the same. So there was no additional analysis which was supposed to be performed. However, if we reject null hypothesis, what do we do in that scenario? Because we know for a fact that if we reject null hypothesis, we proceed with alternate hypothesis, which says that at least one supplier's transaction time is different. So we need to understand on which supplier's transaction time is better, so that your chief marketing officer might go and renew the contract for that particular supplier. Rather than taking the same case study, we'll take a different case study and a different data set, because this data set, using this data set, we have already failed to reject null hypothesis, so we could not evaluate another scenario. So we will try out with this new case study. Hospital turnaround time. A hospital wants to determine whether there is any difference in the average turnaround time of reports of the laboratories on their preferred list. They collected a random sample and recorded the turnaround time for reports of 4 laboratories. Turnaround time is defined as sample collected to report dispatch. So this is the start time, sample collected from the patient to the report dispatch. That's the end time. Now, is turnaround time in all these 4 laboratories the same, or is it different? If it is different, then which laboratory is having the least turnaround time? Of course, I need to look at which laboratory also has highest turnaround time, so that I might proceed and implement some process improvement initiatives there. So we need to analyze the data and determine whether there is any difference in average turnaround time among the different laboratories at 5% significance level. This is alpha. 5% is 0.05. Given this case study, we need to first identify on what is y and what is x. The output variable y here is turnaround time. And the input variable here is the 4 laboratories that we are discussing about. So we have 4 labs, lab 1, lab 2, lab 3, and we have lab 4. The second step would be identify the data types. Time, whenever we deal with time, we know for a fact that time is continuous. So turnaround time is continuous data. And we have x, which is discrete, and we have 4 discrete variables here. Turnaround time is continuous data, and the input that we have here is discrete. This is discrete with 4 categories. This is discrete with 4 categories and turnaround time is continuous. If the output variable of interest is continuous and if the input variable of interest is discrete in greater than 2 categories, then what do we do? Let's see. If the output variable is continuous and if the input variable is discrete, and if we are trying to compare more than 2 populations, this is the particular branch that we need to traverse. We do not jump into ANOVA yet, right? We first check on whether data are normally distributed or not. That's the first step. So we need to first perform normality test. And here we need to write down null and alternate hypothesis as we were doing this. Null hypothesis says data are normal and alternate hypothesis says data are not normal. For data are normal and data are not normal, we'll perform the normality test. So let me go to the Minitab file which has a lab turnaround time. So we have 4 laboratories and we have the turnaround time for all of these. There are 2 ways to do this. Either go to stat, basic statistics, normality test and perform this particular operation 4 times on 4 different laboratories. Or if you want to perform the normality test at one go, then using some kind of graphical representation, then we go to stat, basic statistics, graphical summary. All you need to do is within this you select all the 4 laboratories and just click on OK. Why did we select confidence level as 95 here? Because in our case study, assume that the management has provided you 5% significance level. That means the confidence level is 95%. Alright, so let me just click on OK here. We get to see the outputs of 4 laboratories. Visually also it's very clear that the data are normally distributed when it comes to 4th laboratory because the p-value is 0.419. So let me go back here. So you have lab 1 whose p-value is 0.419. Since this p-value is less than greater than 0.05, what does it imply? That implies p high null fly. That means you fail to reject null hypothesis. Data are normal. Data are normally distributed. All right. This is for lab 4, laboratory 4. Let us check for lab 3. Lab 3 also, when you look at the graphical representation, it appears as if data are normally distributed. Even the p-value says that data are normally distributed. What about lab 2? Oh yes, here also the p-value is greater than 0.05, which implies data are normally distributed. Even graphically it's the same. And finally lab 1, data are also normally distributed because p-value is greater than 0.05. Good. So the first hurdle is clear. We know for a fact that data are normally distributed. If yes, what is the next step? We need to perform the variance test. Are variances equal or not? So the second test would be variance test. H0, sorry, my bad. Turnaround time variance for all 4 labs is the same. Alternate hypothesis, turnaround time variance for at least one lab is different. Okay, so let me go back to the Minitab file and let us perform this. We need to go to Stat, ANOVA, test for equal variances. So let us do that. What is response data? Response data is output variable. And we have laboratory, which is a factor which has 4 levels, 1, 2, 3 and 4. So we have selected the turnaround time of all the 4 laboratories, and let me look at confidence level. That's fine. So let me click on OK. There we go. We'll go with multiple comparisons, and we know why we will not look at Levene's test. If you look at multiple comparisons, p-value is greater than 0.05. P-high, null fly. That means you fail to reject null hypothesis. So turnaround time variance for all 4 laboratories is the same. What do I do if variances are equal? If the answer is yes, we need to perform with one-way ANOVA test. So let us write down that also. So we need to now perform ANOVA test, analysis of variance. Here also we need to write down null and alternate hypothesis. Null hypothesis says average turnaround time of all 4 labs is the same, and alternate hypothesis says average turnaround time of at least one lab is different. Okay, sorry, my bad. Okay, so let us do this. And one more thing is, what if variances are not equal? You have this. You have the flowchart for yes and no in all the places. What if data are not normal? What if population standard deviation is not known? What if the external conditions are different? You have all those different scenarios. So for now, let us perform this test. ANOVA one way. So I go to Stat, ANOVA one way. And here I've selected laboratories for all the 4 locations. And we are assuming equal variance. I don't want to perform this test now. 2 key test. I don't want all of these. I want none of these for that case. Now let me click on OK. I'm interested in the p-value. And p-value is 0. So p-value is equal to 0. 0 is obviously less than 0.05, which implies P low, null go, meaning we reject null hypothesis. And if you reject null hypothesis, we need to proceed with this, which says average transaction time of at least one lab is different. So now the follow-up question is, average transaction time of which lab is the least? And average transaction time of which laboratory is the maximum. Now, in order to perform that, we are going to look at Tukey pairwise comparison. Let us do this.